equations. Can anybody tell me, are they in standard or in transformation?
That's transformation.
What's the difference? One has A, H, and K, and the other is in something that we need to factor. Is this something we need to factor?
No.
Is this something that tells us A, H, and K?
Yeah.
So then we need to list transformations to determine our characteristics. Okay, let's start with the first one. First one, what's your A value? 1. And don't forget the parent. Let me write that down. I'm sorry. Here's your parent. And what do we know about the parent?
We should do the dance at the beginning.
No.
Stop getting off topic. What do we know about the parent?
They're 0, 0.
Their asymptotes are at 0. Okay, so then if we transform it, we have the option of changing those asymptotes if we move it left and right or up and down. Okay, so from that parent function, do I have an A value? Is anything being multiplied to this one?
No.
No, because it's still 1. 1 doesn't stretch you, 1 doesn't compress you, and there's no negative saying that you
Told you.
Shrink. Reflected.
reflected. Okay, so then let's move to the H value. Our H value is
Negative.
-3. So our H is -3. What does that mean we did? We always do the opposite of the H, which means that we translate right 3. Okay, then we have a K value. Our K value is on the outside. So if we're adding K, which is the +3, what did that do to the graph? Shifts up 3. Okay, those are the only 2 transformations. Based off of these transformations, are they going to move the asymptotes or will they still be at 0? Are they both going to move?
Yeah.
Yes. So then based off of this direction right here, it says that we went right 3. Is going right your Y value or your X value? X's, which means our new vertical asymptote will be X equals 3. Okay, what about the HA? Well, if we're going up 3, that's the Y value. So then that means my horizontal asymptote will be at 3 as well, because going up is still positive and going to the right is positive. Question on finding the asymptotes based off of transformations. Okay, then let's go ahead and graph the asymptotes, and then we'll use our calculator to fill in the table. Thank you. She's not here. She already left.
I think I saw her walking.
Yeah. This is for Kayla.
She looked like last period.
Okay, there's the asymptotes. Go ahead and get your calculator out. Remember to put your numerator and denominator inside what? Parentheses. In our calculator, we go to Y equals. In the numerator is just 1 divided by, and the denominator is X minus 3. And then what's outside of that? Plus 3. Okay, so when I go to the table, do I just start with wherever I want? Is it always going to be just the first error I see? Which specific error do we look for? The one that corresponds to your vertical asymptote, because we want to graph both sides of that asymptote. Okay, so go in the table, center it around the 3. Here we go. So in my table, we put the VA in the center, 3 error. Bless you. Okay, and how many points minimum do we want to form some sort of curve? 3. Okay, so right above it we have 2, 2. We have 1, 2.5. And do I want to use that one? We can if we round it. We could round it to 2.7, or we can skip it and use that one. Or I could skip it and use that one. I like that one better. Nobody says you have to use these points. Use whatever shows up on your grid. Okay, now let's go below the 3, graph the other side of the asymptote, which is 4, 4, 5, 3.5.
What if I only chose 2 at the bottom?
Then you wouldn't get a formal curve like
But
you
I
want.
saw the graph.
Yes, but you want to know how far from the asymptotes that graph is. That's why we do 3 points, to see where that curve, how far it comes out from the asymptotes. Okay, I'm going to skip around. 8, 3.2. Okay, do we have any holes? Will we ever have holes with transformation form? Probably not, because transformation, we don't need a factor. So you have no way of having a hole being removed. There's nothing being removed from the original equation. Alright, so let's plot the points, and then we can do domain and range. We got 2, 2. 2 up 2. Then we got 1, 2.5. 1, 2.5. And negative 2, 2.8. Even closer to 3. Okay, so we see the curve happening. Connect the curve and approach the asymptotes. Same thing for the other side. We got 4, 4, 5, 3.5, and 8, 3.2. We see the curve, approach the asymptotes. All right, we graphed it. Questions on graphing based off of transformations? Okay, someone quickly, let's tell me the domain. Domain.
Negative infinity.
Go to the left forever, negative infinity. And then where would it approach?
3.
3.
And then 3.
Union, pick back up at 3 to what?
Infinity.
Infinity. Good. Somebody else besides Nicole, tell me the range. How far down? What's infinity?
I'm sorry.
Okay, how far up it approaches? Pick back up at?
3.
And it goes to infinity. So the domain and range are actually the same in this, but they correspond to the x's versus the y's. Okay, questions on 1, guys? Alright, moving on to part 2. Let's do the same thing, starting with transformations. I'm trying to finish the first 3 before we go to lunch. Yep. We got time. Alright, let's start off. Somebody give me 1 transformation and why.
Reflex and strip.
I said 1.
Okay, reflex.
Okay, why reflects?
Because there's a negative.
There's a negative sign. Just the sign makes you reflect. You go the opposite direction. Okay? Shift down 2. Why? Which value? The k. Okay, so we have the minus k from that negative 2, so it's going to shift down 2. Okay, somebody else?
Stretches.
Somebody else besides Alec, because he already went. Okay, y stretches, Kira.
I don't know.
Well, Alec, can you help her out then?
It's greater than 3.
1. Bigger than 1.
So the 3, your a is greater than 1. Because it's 3, which makes you stretch. And we got 1 more transformation. Somebody new. Translate right 2 because of the h value, minus 2. So translate.
What are you doing? Maybe we have to write it in that order.
No.
Oh.
I'm just putting it on here. Y'all can write it however you want.
Like that.
Because I felt like it.
Making me yum.
My pen's running out. I like this pen. Alright, so then are my asymptotes going to still be at zeros? No, we moved them. Which ones moved them?
Your VA and your HA.
Which transformation moved them?
Your
H and K. Okay, so if I went right 2, then my VA is going to be
X equals 2.
x equals 2. If I went down 2, then my HA is going to be y equals negative 2, and it's officially a goner.
damn.
My pen. I like that pen. Huh?
No, she like put like a pointy.
No, I wanted the pointy blue pen.
Yeah, she had it now, but it used to be like red, brown, white.
It's fine. Alright,
Somewhere in her hair would get like.
let's go graph it. So we got our asymptotes first, x equals 2. Graph your asymptotes. And then we got y equals negative 2.
Oh my god.
And fill in a table. What goes in the center of the table? The 2 will, because that's your VA. Alright, plug it in. Tell me the points that you have on the top and bottom. Do not forget to put that negative inside the calculator. It does make a big difference. Don't ignore it. You can keep it outside the parentheses since it's outside. Yep.
1 and 1.
1, 1.
-1 and -1. And then -4, -5.
-4 and what?
-1.5.
Alright, and the opposite side.
And then 3, -5. And then 5 and -3. And then 7 and -2.
2 point what?
6.
Alright, that works.
7.
What? Oh, you're confusing me. Alright, we graph it. We got 1, 1. We got -1, -1. And -4, -1.5. There's the curve, extend it, approaching the asymptotes. Now do the other side. 3, -5. 5, -3. And those of you that think I'm going too fast, that's because you're copying everything instead of actually doing it on your own as well.
Oh, I'm a fast cop.
Get over it. You see a coordinate, it's why you gotta look at where I put mine. You know how to graph a
You
coordinate.
talking about you wanted to do this together. We can't do this together. If I,
You know how to graph coordinates?
These lines be confusing.
Hmm.
I know she didn't know about me.
I did.
You just did.
Alright, that's transformation form. AHK. Okay, so if I did domain would be from -infinity to approaching 2, and then from 2 to infinity. So domain, -infinity to 2, and 2 to infinity. Range, how far down?
-10,
To,
-2,
from -2 to,
infinity.
alright, so -infinity to -2, from -2 to positive infinity.
Do what? No, girl, because it didn't come out right. 'Cause we didn't-
Okay, so the last thing I want to do before we go to lunch is actually factor number 3, and then when we get back from lunch, we'll do the rest of the characteristics.
Come on.
Can I move this? Alright, so on number 3, why is this one not in transformation form? Because it get what?
You got exponent.
Oh, I know what
You don't have the H and K happening, and what did you say back there, James? You can factor it. So parent function is not something that we're going to factor. This, we need to factor. It's in standard form.
Difference of squares are stupid.
Why is it difference of squares?
Because those are perfect squares and
They're both perfect squares. Okay, what's the GCF on both of them?
Oh, wait, 1.
1. Okay, so then using difference of squares, we want to put it in something where we have a plus b times a minus b. How do I find the a and the b values? You square root the terms. So I square root x squared, my a is. I square root 4, my b is 2. So then a minus b would be x minus 2. Do the same thing in the denominator because it's also a difference of squares. Square root of x squared is
30108
x. Square root of 9 is
3.
3. So then over here I'd have x minus 3. There we go. We factored it. So when we get back, we'll use those questions that we had for what makes it undefined to find the characteristics.